Okay, I'm just waiting a couple more minutes for people to join the chat. Great. A few people on the Twitch now. Can you guys hear me okay? About to start. There's a little bit of lag. Okay, someone said they can hear me, so let's get started. I must admit, I have actually looked a little bit in the past month at some of the NFS code. So I do know that there's some interesting sort of coding constructs that aren't necessarily great. I haven't really done much documentation on this. Looking at it a little bit, but let's have a look. So we're going to look at file system. There's a few bits and pieces here, so let me just see. We're going to go to NFS common to start off with, I think. Or maybe not. Maybe not that. So what else is there? NFS. This is the thing, so let's just have a look for allocs, sort of a pretty good sort of place to start. What have we got? Kmalloc array. That's a secure sort of coding style now. Kmalloc. I'm sort of just getting a feel for what parts to audit at this point. There's quite a bit of these sort of functions. NFS process. Oh, I like that structure. That looks interesting. That NFS or encode allocate could be interesting. Let's have a look at Kmalloc. Just look at mem copies. A few mem copies. It's quite good. Just getting a feel for what APIs they're using. Mount client. Let's have a look. I'm just generally looking for mem copies where the length field is not fixed or static. So size I would generally indicate that it's not going to be useful. Oh, I like NFS for XDR. But there's a lot of mem copies, so it's definitely worth looking at. What else can we look at to start off with? Are there any copy? Some. These are an API to copy between user land and kernel space. We'll just do copy from. Nothing too much there. Oh, there's a I think have I looked at the NFS code before? That flex file layout, I'm pretty sure I found a bug in that already, if I think about it. I'm pretty sure I have, to be honest. Let me just have a... there's nothing there. So let's have a look. What else can we look for? LE32, 32, big Indian 32. There's a few of these. Okay, let's just look at NFS. Let's just start auditing a little bit. So we're looking for big Indian 32. This is okay. I'll see some sequence number stuff. Oh, nothing really there. Big Indian 64, nothing there. LE 32. What else can we look for? Let's have a look at that extent tree. Oh, actually, that's size of B32. That's not very good. Looking for a good bug. Count equals BE32 to CPU. Looks good. Anytime there's a length where it's coming from, that is useful. Layout BE32. Verify extent. Okay, so, oh, this is sort of silly, to be honest. Now we're looking for a sign bug, an overflow bug here. So do we have it? So count is signed, unsigned 32, and so there is a bug already. So it's a simple bug, but it's a bug. I mean, you know, you can't. So it's a simple bug, but it is a bug. So have you guys? Do you guys see what it is? So simple bug. I'll just put the file name. Block layout.c. This is sort of, yeah, this is a sort of a classic style of bug, to be honest. It's not really that. So simple bug. Pretty happy with that one, I think. Should I just move that across? I wonder. Okay. I know. I should use the tiled window manager. I'm sort of technology frightens me. Count is unsigned 32-bit. So this looks like a denial of service. I is signed, and yes, this is good. Maybe what's going to happen here? So there's going to be a promotion, an integer promotion, size unsigned. So I think it's okay. I don't think it's actually a bug, to be honest. Let's have a look. So I think the signed value will be promoted to unsigned. so let's do x once on jar count equals 130. I think this isn't going to be a problem, but you know, it's not great. I mean, you wouldn't want this to. Okay, it is actually a problem. So we have, it is a problem. So have I done this correctly? No, it is a problem. So it's great, awesome. It is a bug. I have looked at NFS before, I must have. This will lead to an infinite loop if count rate is right. Okay, that's not a bad bug. Okay. Okay, so that's good. That's a good, simple bug. What else do we have? Let's keep on going. Good bug. Very happy with that to start off with. This is a classic sign bug, I suppose. So anyway, keep on going. But to be honest, like, who knows if you can be able to allocate like Intmax alloc extent. So it probably won't work. So even though this is a bug, if you could do this for Intmax times, it's probably unlikely to happen anyway. But it's still considered. Maybe it wouldn't be exploitable, but you'd still fix this if you were a developer. Now, what is LGR? KZ alloc LGR. NFS for layout. So, I mean, that's probably okay. Okay. Let's just look at BE state. I mean, I don't know if this is something. Decode sector. Offset length. So we can control offset and length here, I presume. Okay, so there's an integer. Oh, there's not an integer overflow. Offset is greater than start. There are some bugs here, I think. Let's have a look. So let's assume we can control NFS. It looks like there's all integer overflows here. Let's just see where we set this up. So we're reading offset length. So we got offset length. Where does cow read come from? Copy on write, I presume it. 64 bits. Okay, layout verification. Start inval. Okay, let's just do this. I mean, you can tell that there's bugs here. It's just because it's clear that the authors haven't looked for integer overflows. Layout verification. So that's good because it's an internal structure. Layout verification. Okay, so this is LGR. We all assume we can control offset. So we have, let's see where we are. So we have this. LV. So it checks for offset plus length from that LGR. So we can't, just trying to understand the code and not read it too much. So we control start. So we control offset from range, and offset makes start. We control, so offset plus length. Let's just look at alloc extent for a start. So if we can do anything in that one. Alloc extent. Okay, so BE. Okay, so we can do alloc extent, so then it does the verify, and then it adds that to the list. Let's go to verify extent. And this is where we want to get those integer overflows. So I normally don't like reading this too much, but maybe it's that. So, and then it does that check, but it does that process extents. Does it change the status? Okay, this isn't too bad, I think. Okay, so this check here, just highlight it. It doesn't really matter. So I mean, it's actually yeah, it doesn't really matter that we don't reach this part if this fails. So what all we really need to do, and we've got this extent tree insert. So that's what we want to insert. Tree insert. What can we do? So we're looking now for some sort of memory corruption to see if we can So let's just ignore if we can if we can get memory corruption and actually just try to record what this bug is. So we don't have to worry about this offset plus length. What we're trying to do is to do a pages. We want to go to alloc extent. Okay. Let's just record this. This is what we want to. That's what we want to do. So we can control. Let's just add a comment here. We control. Well, actually, maybe we probably have to have a look at this. Decode sector number. Okay. So all it's doing, so we don't have full control over this. We control offset, F offset. What's it? V offset. But not the high bits. Each variable okay. I think people are commenting um, on the stream things. I don't actually have it open all the time when people are making comments. Um, so I always have to go back every 5 minutes to see what's going on. For the people that have just caught up, looking at the NFS code for the Linux kernel, and earlier in the stream, did find an interesting bug where it reads this count, which is an unsigned integer, and then does this loop using a signed integer and comparing it to that unsigned integer. And effectively, if you go greater than int max for that count, you can cause an infinite loop. But you're probably not going to be able to trigger it since you probably won't. You'll probably run out of memory before. Maybe you won't run out of memory, but it will be hard to trigger. Does that get everyone up to speed now? And I'm looking at this other bug at the moment where it looks like there are some integer overflows, but it's trying to figure out how exactly, if there are, it looks like there are going to be integer overflows. There's no checking at all of these types of bounds, so I presume there are bugs here. So okay, so this is the code that we're going to have bugs in, I think. So this is the code, I think. So now what do we have? Okay, so let's look at this particular bug. Start plus equals length. Can we get that to integer overflow? So let's just start up here. We just do is start. We really need to know what the length is as well. So BE PNFS block extent. Block layout extent tree block extent. Was that the one? What am I doing? Getting a bit crazy here. So length, okay, so I don't normally look for bugs this complicated. It's not a complicated bug, but it's sector T. I don't, maybe it's okay. That's good. 64-bit integer. I'll just copy that across. If you are a kernel coder, you would know all these types pretty much off by heart, to be honest. I mean, they're not complicated types. And with modern hard disks and file systems, you want everything to be 64 bits. Okay, so start eval. And I looked at the wrong thing. Okay, great. Awesome. I'm looking for NFS for layout get res. NFS for layout get PNFS layout range. Okay, here we go. And that's good. So offset and length are both 64 bits. So okay, so alloc lreg, alloc extent, where have I done? Alloc lseg. I'll just copy that in. Okay, so we go to alloc extent, we control start. Where is verify now? Okay, so this is the part we're interested in. So, can we get an integer overflow? If we control some of these things, such as if we control this so what do we think we control here? So we're going to assume that we control the sector numbers, which is offset length and offset. Then it verifies that against that layout verification. So we control the extent, and we want to modify, we want to get the layout verification to integer overflow, I presume. So LB start is up here. And that's offset by that sector shift. So we don't control the high bits. So can we... So I don't think we can cause that to integer overflow, that part. And if they get out of this without getting any bugs here, so the problem is this sector shift is killing those high bits, and we generally need high bits to cause integer overflows if we're using addition. Start and length. Okay, oh, wait up. We got, do we control length? I cannot believe they may have escaped. They may have escaped this integer overflow. There is another bug that could happen though. So what about when the sector number is 0? This if the sector number is 0, that could be an interesting bug. So let's go through this again. So we don't really control this layout verification. Going to alloc extent. In the alloc extent, we're getting this sector numbers. We can make offset length and v offset all 0. Then it verifies the extent. I'm just going to say there is a bug. It's not exactly a big bug. I mean, this is sort of... Is it a bug? Is it a bug? No. Sector number 0 can be 0. Can't it? Absolutely, it can be 0. Yes, it can be 0, but I'm not quite... Yeah, no, that's totally okay. If b offset is greater than start, it's an error. If offset is less than invalid, there's a set of bugs here, but yeah, okay, so well, it's okay, it's a small bug, but bug is what does it mean to have a block extent length of 0? Be any checks. maybe not. Okay, let's go. Let's keep on looking. So let's keep on looking. Okay. Let's have a look here. File layout.c p32. Here we go. Something to look at. It's not a bug, but I'm not quite sure how to. First stripe index. This is sort of interesting. It just means that you can probably do some sort of NFS identification, because the way that it handles these flags, it assumes that if this bit isn't set and this bit isn't set, it must be meaning this, which isn't. I don't know if that's true. Maybe it is true. Who knows? Stripe unit. Oh yeah, it uses that. I don't know. Who knows? Pattern offset. Num FH. What is FL? There's no way that this is going to be a sign bug, but you never know until you check. Oh, what have I done? You never know. Sometimes you find bugs like this, but it's not too often. So num FH is a unsigned integer. They really should change this to maybe U32 or something. Not much here. This might be interesting. If we control a size, so we can make size quite large. Well, let me just look at this. There's got to be an alloc here, surely somewhere. Am I imagining things here? I'm missing something. There has to be an allocation somewhere. FH array data P. So P must do the allocation. Okay. What is P? P is beginning. So if I can get, this is XDR inline decode. Now if we can get this to return a buffer that's smaller than the size, given that we can control the size, we could get something good. So this is actually needing another bug now. is this code? I've had this before, and it's somewhere. Here we go. XDR, inline the code. Where is it? This is why I need to use C tags or something like that. It's not in lib, I checked lib already. Where could it be? It's not in driver, surely. Net. Oh, here we are. XCR inline. XDR inline to code. That's the one. So we control n bytes. This is our key here. So if n bytes equals 0, just returns xdr/p. That's not useful to us. If xdr/p equals xdr end, so this is like a network stream, and then it's causing the real function. This one. Only the real function. So quadling, so changing n bytes to a smaller thing. P plus n if q is less than p. So there's a check for integer over. There's a check for an overflow here. So okay, I don't think we can do anything here. Oh, it's an interesting one. Look at it one more time. if n words is greater than that, or and if it's greater than the end. Oh, wait up, we've had a great comment on the Slack talking about int and unsigned int and char and unsigned char. Very possible, very possibly true. I'll just check. So let me just check that. Let's just see how long that will take to... that could take some time. No, it's way too long. What do they call it now? Ah, yes, absolutely. So it doesn't work. It is. I've had this issue before. So yes. So it's an annoying thing with integers specifically. Absolutely. So that first bug absolutely is not a bug. And thank you for the person on the stream. Absolutely. So that is not a bug. Now I feel motivated. They have to find something good. Okay, let's start looking at well, this is an interesting one. Another sign issue. So what does it mean if nlen is negative? What does it mean here? So nlen can be negative, which is probably not good. So let's go to inline decode again. N bytes. I'm pretty sure I've looked at this particular bug before. I might have even streamed it but not uploaded it to YouTube before. I'm not quite sure. This is sort of all the bunch of bugs that I was finding earlier. Well, here's a bug already. So nlen plus 1 is an integer overflow. So that's clearly a bug, but can you trigger it? Does this inline decode actually do anything? So okay, so inline decode, we go to here, we check for n bytes equals 0. So we want to make this uint max nlen. Like n bytes equals 0. I mean, I don't know. You'd have to assume, well, I don't know. Should we treat it as a bug? I don't know. Well, let's see what else we can do with it. If nlen is negative. Okay, well that's a bug right here. So okay, so this is conceivably a bug. Now, can you get a int max to the? I mean, it's not good code. I mean, you'd want to not have this in your production code. NFS nfs.c. Nlen is negative. Like this is like a theoretical sort of bug. Sign conversion potential overflow negative index if nlen is negative. Yes, I reckon this is worth, simply worth submitting to reporting to Linux guys, but let's keep on looking. Darwin. Yeah, this is surely a bug here. I may have audited this code. It does seem very familiar. Sign conversion. Ln is negative and it can be negative. Potential overflow. Okay, I think I found a good part of the code. It's not bad, it's not great. Looking at this code a bit more now. Oh, it's such a, I mean, when you see string lengths and can you get a string up to to 2 billion characters and cause sign and integer problems? It's one of those theoretical ones. Okay, so what else can I look for? So I feel a bit better now. I mean, I always stuff up those integer promotion when it's signed and unsigned. I mean, it's I always do it, to be honest, and I always end up writing code to try to do it. Okay. What else can we do? Let's just. I think I've done this. I'm sure I've looked at this. Callback SDR. Oh, good. That's pretty good. Callback xdr.c be32. What is that? Decode string. This is sort of interesting. Size equals. Okay, so it's a buffer. Well, it's okay. It's reading a buffer of 4. So there must be a helper function up here. Read buff. Okay, xcr inline, looking for sign bugs or anything like that. Oh, buffer overflowed. Wait up. Oh, yeah. Okay. Buffer overflowed. What else can we do? To me, that's like a silly sort of I don't know. It's hard to say. Like, It's such a simple API, and all it's doing is just adding an error wrapper around it to print a warning. Um, I'm not a huge fan of those, but sometimes they're okay. Okay, so struct NFSH. Unsigned short. Okay. NFS FH. FH data. Okay, you know what I'm seeing here? So the question is, does NFS for FH size, is that the same as NFS max FH size? Max NFS FH size? What about, I could get so lucky here if it is, but I'm not holding out for it. Damn it! It's so annoying. Anytime they're using different macros, it's always a potential. Oh well. And so you always, someone should write a just a some program analysis code to look for comparing the size of and the array is declared with a different macro. You have to wonder why there are like FS max. Oh well. Okay, there's no way that this bug is in this kernel. I'll show you this is hilarious. I just saw that mem set. Now, can you actually find yeah, that's good. No, it can't be. No, I don't think it is. Where is it? Oh yeah, it's nah. I'm sure there's a thing that's good. Let's just do. We'll leave that run and see if we find anything. Nah, damn it. It was worth a shot. It was worth a shot. Okay, let's look for some more stuff. Decode bitmap. Lateral length. Lateral length. Nothing really much there. Mem copies. Op we can probably control. Len, what is len? Is it it's an unsigned int. about that. It's probably okay. We'll assume that it's okay. Let's look for mem copies. Those Minty sometimes have bugs, but this one doesn't. Key unique len. Was this surely a this looks like a bug. Let's just look at FS, what is that, FS cache? Key. Unique len is a, no, so it won't overflow. That's a bit annoying. Who makes, like, chars uses, 8-bit? So, well, sometimes they do it. We'll assume well, hello? Hey, how's it going? Just give me, I'll finish off this thing and I'll come over. Yeah. I'll talk to you soon. I'll call you back in 5 minutes. See ya. Okay, so sorry about that, guys. I actually just got a phone call. Look, I think I think the NFS code there's more stuff there. And it's certainly worth looking at it more. There are certainly some bugs here, and I'm sure if you continued looking at it, you would find a ton more. We did find a couple of things that probably are worth fixing, but we'll go from there. Okay, guys, I might wrap up now. Thanks for viewing it. Appreciate it. I do have a Patreon site where you can donate money to me. Check that out if you can. I'll probably continue auditing NFS another time. So thank you for very much for watching. I'll see you next time.